So we've just symbolized this long argument with 6 premises and 7 simple statements. And we would like to now be able to determine whether this argument is valid or invalid. To do that, instead of making a truth table with 128 rows, we're going to expand on those rules of replacement that we already developed for analyzing the form of an argument. So the rules of replacement we already have is we can replace any statement by an equivalent statement anywhere in the argument, anytime we feel like it. The other rule of replacement we have is that we can replace a statement by any other statement as long as we do that everywhere that it appears, and we're a little bit careful with things like negations. So we can do this. Certainly we can do it as long as we're replacing every appearance of some particular simple statement. Now, the big rule that we're going to need here is that we can follow through on any valid argument. If somewhere in our premises we have all of the premises of any valid argument, we can also add in its conclusion as if it were just another premise. And what that will let us do then is to recombine that with the other premises we have and get additional valid argument forms. The other 2 things we have here are just kind of utility moves that will make it easier for us to line up that move specifically. One of them is that we can change the order that we're writing premises in just in order to make argument forms more obvious to us. And the other one has to do with conjunctions. If we have 2 statements, we can combine them into a conjunction. So if we have P as a statement, and we have Q as a statement, then we can put in P and Q as just an extra premise. And if we have P and Q as a premise, we can split that up, and we can have just P as a premise, just Q as a premise. And so we're going to make heavy use of that third rule of replacement, and then just kind of light use of the other ones as we work through this. Using that third rule, we can reason like this. Looking at our great big complicated argument, we see that these first 2 premises look like the premises of the argument form that we called direct reasoning. That's the form where we have a conditional as a premise and the antecedent as a premise, and we can conclude the consequent. Because here we have this conditional, and also we have P and Q, which is its antecedent. So if we know that P and Q is true, and we know that if P and Q is true, R has to be true, we can then conclude that R has to be true. So that's how that move 3 works. I had the 2 premises of direct reasoning, and I used them to introduce the conclusion. Okay, well, looking at that then, we have a lot of valid forms that use conditionals, and we certainly have a lot of conditionals in this argument. I think we actually have another instance of direct reasoning that we could use, because we have if R then U, and we have R. I'm just going to reorder those and move R down to sit underneath if R then U. And the reason I'm going to do that is that makes it more obvious that here I'm looking at the premises of the argument form direct reasoning, and I can introduce the conclusion. If R is true, then U has to be true. R really is true. and therefore U has to be true. All right, let's see, what else? Well, looking at our conditionals some more, I think that we have, we've used this one in direct reasoning and this one in direct reasoning. This one, we don't have T anywhere in our premises, so we can't use that in direct reasoning. Oh, but we do have a not S. We can use that in the argument form we called indirect reasoning. That's the form where we have a conditional, and then the consequent is false, and we conclude that the antecedent must also have been false. I'm just going to switch the order of these two premises to make it really super obvious that we have the premises of that argument. And then by combining those premises, we'll get the conclusion. So we have the negation of S, and we'll conclude the negation of T. Okay. So I feel like chasing down those conditionals was kind of the low-hanging fruit. And I've done all of the chasing that I can now with my conditionals. And I have a lot of either simple statements or their negations. And that tends to make my life pretty easy if I have a lot of simple statements or their negations. Now I'm going to look at how I can actually get my conclusion that I want, my conclusion W. And looking at my conclusion W, it only appears in one of the premises, that one there. And that's a disjunction, which suggests that I'm going to want to use disjunctive reasoning to get to our conclusion. Our valid form of disjunctive reasoning, well, if we have a disjunction and the negation of one of the parts, we can conclude the other part. So in order to conclude W, we would need to have the negation of this if U, then T. Okay. How on earth can we get that? Well, let's think about what it means to negate if U, then T. Remember, when we're working in logic, we don't have anything nice like a distributive property quite. But we do have a way of negating any compound statement. This is one of the ones that you found in the homework. If it's not the case that if U, then T, then, well, the only way that the conditional can be false is if the if part is true and the then part is false. If it's not the case that if U, then T, that's equivalent to saying that U is true and T is false. So U is true and not T is true. But we're in luck, because in fact, we already have that not T really is true, and U really is true. So combining those, we can just combine those into a conjunction, U and not T. And that's equivalent to not if U, then T. And we're there. We see that, in fact, noticing that this right here is an example of disjunctive reasoning that gets us to our conclusion, our original argument is valid. So, presented with this argument, remember this is the argument that we're working on, Should we really give Jamie a raise? Well, there's one other thing, of course, that we need to know in order to know that the conclusion is actually true. And that is that the premises are also true. But as long as the premises are also true, then yeah, we should give Jamie a raise. This argument actually is valid. It really does get us to the conclusion that we wanted to see if it would get us to.